All right, we're going to work on problems 14 through 21 on this one. Several of these ones first focus on the definition of that p-value. So the interpretation of p-value. So p-value is that the probability of getting that the sample we get or something more extreme if the data is really centered around the null hypothesis. So therefore, we need to understand the context of what's happening, and it's about the difference between the proportion of people on the West Coast and the proportion of the people on the East Coast who have test-driven an electric car. So the null hypothesis is that that they are equal to each other, that there is no difference between them. So that's what I'm kind of looking for here. I have highlighted in green if the null is true. So I'm looking for the words that say what I've highlighted in green here, if the proportions of all people who test-driven an electric car is the same for both regions. Difference is P of W equals P of W, or P of E. Okay, so answer choices A, B, and C all have that if the null is true. D and E don't, so they're out. Now, the probability of getting these sample results that we got. So the sample results we got was a difference of 18% between them. The West Coast was 0.18 or 18 percentage points higher than the East. That's what the p-hat we got was. P-hat for W, what our sample results showed that the p-hat for W minus the p-hat for E was 0.18. Okay, so that's why we have in purple here is the difference of at most 0.18 of at least 18 and difference equal to 0.18. So that indicates this more extreme. And because our sample is wanting to see if the West Coast drivers, the probability that the West Coast drivers are greater than the East Coast, that's a greater than. So we want at a difference of at least 18 percentage points. So that's why it's C, a difference of at least 18 percentage points. So this is the same idea, the difference between the defects in the Dallas factory and the Fort Worth factory. So we have that p-value, and so we know that if the null is true, then the defect rate at the factories are the same. So that's kind of what I started hunting for first. So if there's no difference in the proportion of all defective shoes made at the two factories, no difference in the P's, the proportions, no difference in the proportions, okay. And then we want to see the probability of, is the probability of observing of 0.023. So they all say that. But here's the difference, equal to, at least, or at most, the difference they observed. They observed a difference of 0.004. So, but because they wonder if Dallas factory has greater proportion of defects than the Fort Worth factory, then their difference is greater than 0. So that makes it such that the difference is at least 0.004. So there we have that, greater than or equal to, or just the greater than. All right, this one's the same thing. Interesting thing here is they say in the prompt that the null is true, so we don't even have to find that. We have to find the other two things, the probability and then of getting this sample results or something more extreme. And so there we have that as B. This one was a mess because when I went to go make the answer key for this, I realized that, yikes, the negative sign ended up on the previous line. It got cut away from that 0.04. So if you were wondering, how did they make this interval with a positive 0.04 in there? Okay, because that's what I was wondering. So it's actually a negative 0.04. So when I subtracted it, the 0.12, I get negative 0.16. Added it, I get 0.08. So our interval is from negative 0.16 to positive 0.08. So we are asking about an interpretation of the interval. And it's the interval for the difference between those the percent that their districts are spending, District C and District M. Okay. Responding yes to the proportion of who are responding yes to the question. Okay. So first I need these numbers, negative 16 to positive 0.08 in the conclusion or in the interpretation of the interval. So that's C, D, and E. A and B are out because they do not have the interval in them. Now, you have to, remember that anytime a problem is about the difference between two proportions, then you should be having those words that this is an indicator of the difference, the size of that difference. Part E didn't talk about that, so I'm down to C and D. And then once I get down to C and D, then I'm wondering if okay, so here it has the difference in the sample proportions. An interval is not about other sample proportions being in there. An interval is the true proportion of all voters in that interval. So I am 95% confident that the difference between the proportions of all voters in District C and M who favor the increase is between negative 0.16 and 0.08. Of course, then we know what that conclusion leads us to, which is what the next few questions say. So 0 is in the interval. So if 0 is in this interval, there is no significant difference between those two proportions. So number 19, same thing. Here again, do you see how whenever they have two proportions, they are referencing the difference between them, and they say which way they subtract. That's why we always do that. And so here we again had a 0 difference in the interval. So there is not evidence of a significant difference. And so then here we have this one, number 20, which comes from the formula chart. So I was going to pull that up for you real quick and let you see that. So this formula chart has, of course, the formulas. And let me move. There we go. So the top half of the back page has got our proportions. Of course, this top one is for one proportion. This second one is for the difference of two proportions. So this is the sample results we get for the difference between two proportions. And then we need to do so if we're making an interval, so see what this problem is doing, is it's making an interval. So see, we would have our difference between the things, between the two proportions. Then we would have a critical value based on, and in this case, a 99% confidence level. Don't you dare inverse norm 0.99. Yes, 0.99 is what's in the middle, but we're going to inverse norm one tail, 0.005. So that's why then we have that inverse norm of 0.005 is 2.576. If you inverse normed 0.99, you got answer choice B for a critical value of 2.33, which is wrong. Okay, and then FYI, what's inside the standard deviation is coming from this here, where we have the information, the successes, failures, and sample size for group 1, the successes, failures, and sample size for group 2. And that's what this shows here. Okay, next, number 21 is a pretty straightforward, just setting up the hypotheses statements. So we were really kind of, so our null hypothesis, of course, would be that the UK kennels, the genetic inbreeding in the UK kennels is higher than the genetic inbreeding in the American kennels. Okay? And remember that the null hypothesis is always 0. So again, the null hypothesis is that the two that the two countries have the same inbreeding rate. Okay, but the alternative is they speculate that, let P view, okay. Oh, they're wondering if UK is greater. So the proportion of U greater than the proportion of A, which of course means the proportion of U minus the proportion in American is greater than 0. So there we go. All right, that's the end of this video. And so then I will see you on the flip side with number 22 to 25, and we'll talk about those. Number 24 is particularly interesting. So I look forward to going over that with you.